Hello everyone, welcome to Yebo Physics on a Thursday afternoon. I hope I find you well and I hope you are excited to be joining in on our tutorial sessions. So first I would like to introduce myself. My name is Arnold and I'm a postgrad student in the physics department, and I'm happy to be joining you in the Yebo Physics tutorials on a Thursday. So first and foremost, I can see I've got some company on Teams. I also have got some company on the live stream on YouTube. So I therefore would want to check if I'm audible. Are you guys able to hear me? You can unmute your mic and just mention if you can hear me, or you can just react by showing a thumb if you're on Teams. You can just react. So, oh, thank you. I can see some thumbs there on Teams. So I'm audible, and I believe that my screen is also visible, which I'm sharing. So like I said, my name is Arnold, so I'm going to be with you this afternoon, and we would like to interact together as we solve these physics problems together. So the first tutorial, if you realize that it's on units, measurements, and vectors. So that's what we want to look at. And today's tutorial, we'll be looking at question 6 to 10. So I'm already showing the first question that we have there. I'm showing the first question, and it reads, while exploring a cave, a spelunker starts at the entrance and moves the following distances in a horizontal plane. She goes 75 meters north, 250 meters east, 125 meters at an angle of 30 degrees north of east, and 150 meters south. Find her resultant displacement from the entrance of the cave. All right, so the figure is not shown, but we're going to draw it. All right, so this question will involve us to have our knowledge on vectors and resolving. So I'm going to draw the Cartesian plane that we have for that diagram. This is my x-axis. Rather, let me put it here. I'll put my x-axis. Or rather, before I do that, I can just put the origin, which is here. And we're told that he moves 75 meters up north, right? That's what the question says. 75 meters. So this is 75 meters up north. And we're told that she changes direction and moves 250 meters east. So that's 250 meters east. And this is 250 meters east. And then from there, we're told that she moves at an 125 meters at an angle 30 degrees north of east. So north of east, it's going to be in this direction. And this is at an angle of 30 degrees. So this is our angle there, 30 degrees. And then we're told that moves 150 meters south. 150 meters south, so which means from there. So this is 150 meters. So the question says, find the resultant displacement from the entrance of the cave. So from here, we should now be able to find the resultant. And how do we do that? First, we have to deal with a displacement in the x direction and displacement in the y direction. So we're going to sum up the displacement in the x and sum up the displacement in the y. So if you look at those forces, summation of the displacement in the x will be equals to, so this 75 meters is in the vertical direction and it has no component. It has no component. It has no component in the horizontal direction. Okay, so we've got 250 meters. Okay, plus this 130 degrees, it was 125 meters. 125. But you can see that it's inclined at an angle of 30 degrees, which means that we need to resolve it. So we need the component of this vector in the horizontal direction. So we've got this 125 meters at an angle of 30 degrees. So we need to find the horizontal component, which in this case I'll just call x. Okay, that's the horizontal component. And if we are to form a right angle, then we can use our trig ratios. All right. So which sides do we have? We've got the adjacent, which is your x, and we've got the hypotenuse, which is 125 meters. So the x component of 125 meters, you can then use your cosine ratio. So the cos of 30 equals to the adjacent, which is x, over the hypotenuse, which is 125, which means that your x will be 125 cos 30. So I just did this so that I remind you of the resolving of vectors. So when you're resolving a vector, you're basically finding the x and the y component of that vector, isn't it? So which means that the x component will be 250 meters plus the x component of that vector, which is 125 cos of 30. So you can then punch this. So if you've got your calculator there, you can also punch to confirm what we get. So it's going to be 250 plus 125 cos of 30. You get 358.3 meters. All right. Right, then you do the same for the y component, which is going to be equals to 75 meters, which is in the positive direction. So it's going to be 75 plus this 125 again in the y direction. All right. So you can see that now we're looking for the vertical component of this 125 displacement. But now we can look at that diagram, then solve for y. So you now have got your opposite and hypotenuse, which means the trig ratio you use now is sine. So sine of 30 is equals to the opposite, it's y over the hypotenuse, which is 125. So which means that your y there is equals to sine of 30. So which means that sorry, I missed the numerical value, which will be 125 sine of 30. So which is 125 sine of 30, and we're told that this person then moves south, which is negative, because this is displacement. In case you're wondering why it's negative, that's displacement. So once you've done that, now you can punch your values. You can now punch your values. That would be 75 plus 125 sine 30 minus 150. You get negative 12.5 meters. Remember, this is displacement. So this is the resultant displacements that we have. So you can sketch this again, which is your resultant. Your x is positive. Your x is positive, which is 358 meters. And your y is negative. Your y is negative, which is negative 12.5 meters. So which means that our resultant will be in between the two. So what are we asked to find? The resultant, right? So your resultant three five eight squared plus your negative 12.5 squared. Twelve point five squared. So the answer you get as your resultant there is 358. 358 meters. And that becomes your resultant. Okay, so this also can be represented as in that form. If you want, then you can close there. So this is your, let's say, alpha, and you've got your opposite over your adjacent, which means alpha or tan of alpha will be equals to your 12.5 over 358. So which means to get that alpha to be 12.5 to be tan inverse 12.5 over 358. Then you punch that. You get 1.99, which is 2 degrees, but that is not our answer. Remember that when you're looking for the angle, you move from the positive x-axis. So our Cartesian plane was like this, and this was the entrance of the curve here, the origin, that's the entrance of the curve. So which means your angle will then be in this direction. So this is the angle that we're looking for. So which means that will be 360 degrees, your angle theta. Your angle theta will be equals to 360 degrees minus the 2 degrees, which will give you 358 degrees. So the displacement is 358 meters, and the angle as well is also 358. Right, so let me know if you've got any questions or queries on that question, and if there is none, we will obviously proceed. But basically, this is how you would solve such a problem. So if you draw a correct diagram, your problem is already half solved. Okay, I don't see any objections or comments on the chat. Therefore, we shall proceed. Let's look at question 2, which is question 7 in this case. Right, so let's see the next question. So question 7 reads, a rectangle has a length of 1.323 meters and a width of 4.16 meters. Using significant figure rules, what is the area of the rectangle? So area of a rectangle is equals to the length multiplied by the width. So determining this simply by looking at the length, which is 4.16 multiplied by 1.323. If you punch that, what do you get? 4.16 multiplied by 1.323. we get 5.50368. But however, what does the rule of significant figures say when you've got multiplication or factors that you're multiplying? So you round off to the least factor, to the factor with the least number of significant figures. So which means you round off to the factor with the least significant figures. So which factor is the least number of significant figures? It's 4.16, which has got how many significant figures? 3. So when you round off this value, it means your answer becomes 5.50. So you've got 3 significant figures. That 0 is coming after a comma and after a significant figure, therefore it is significant. So this becomes your answer. So you can check that indeed our answer is correct. Don't forget to put units. So that is for question 7. So remember, for multiplication and division, you round off, you give your answer to the factor with the least number of significant figures. Now let's move on to question 8. That is if there are no questions. So that's question 8. Please read through to understand the question. If the question is not clear, let's just bring it, adjust it a bit. Okay, there is the question. So the question says, given 2 non-zero vectors A and B, such that the magnitude of A is equals to B, it's equals to A, and it's also equals to the magnitude of B, the sum of vector A plus vector B satisfies. So we need to see what that summation satisfy, the summation of vector A and vector B. So if we were to rearrange, just write down what we're given. Vector A, or the magnitude of vector A, we're told is equals to the magnitude of vector B, which is equals to A, which is also equals to B. In simple terms, that's what we are told. All right. But the question is asking us about the summation of vector A and vector B. So vector A plus vector B, that is what we are being asked to find. All right. So using the equation of vector addition, that is our vector A plus B, their magnitude. We won't derive the equation, but this is the equation for vector addition of the magnitude, which is A squared plus B squared plus 2AB cos of theta. All right, but remember that your vector A, or the magnitude of vector A, is equals to B, or magnitude of vector B, which is equals to vector A, which is what I put up earlier on, which means in place of B we can put A. In place of B we can put A. So sum of these two will now be equals to A squared plus A squared plus 2A squared, because in place of B I've put A. That becomes 2A squared cos theta. So I've simply substituted A for B. Okay, then we can simplify that, which I'm pretty sure that you can all simplify. 2A squared plus 2A squared cos of theta. So our A plus B will be equals to, you can factor out to make things easier, 2A squared 1 plus cos theta, if you factor out that. Now let's look what would be the possible values. Remember, the graph of cos theta, it's from -1 to 1, right? Let's look for possible values. For example, like I said, if you had to have your theta or your angle in degrees, it's going to be equals to that. Theta should be within this, and cos theta therefore would be less than or equals to 1, or greater than or equal to -1, which means we can then substitute the minimum value or the maximum value, which is 1, and the minimum value when cos theta is equals to 1, -1. So when do we have a minimum value? Minimum value when cos theta is equals to -1. So we go back to our equation. When cos theta is equals to 1, A plus B will be equals to 2A squared 1 plus, so when cos theta is equals to -1, -1, which will give us 0, to be 2A squared 0. So which means that our minimum value will be 0. Okay, when cos theta is equals to -1. Then let's find the maximum value. maximum possible value. When cos theta is equals to 1, what will be the maximum value of A plus B, which is equals to 2A squared 1 plus 1, which will give you 2. So which means this will be equals to the square root of 4A squared, which is equals to 2A. So that's our maximum value. So which means when you look at the range of values for this summation, it will be greater than or equal to 0, but less than or equal to 2A, which is our maximum value. Therefore, a summation of vector A and vector B is less than or equals to 2A, which is the maximum value, but less than or equals to 0. So that is how you would analyze such a question, by taking it from the equation for vector addition of magnitudes. So that's how we've gone through that question. If there are any comments, questions, please do let me know. So in the meanwhile, while I'm waiting for questions, I'll just scroll to question 9. I'll scroll to question 9 while it's still thinking about any questions. So I've put up a sketch of my diagram there for the question, which is being shown, question 9. And the question is asking for the resultant angle. Resultant angle. So again, just like we did on the first, was it the first question? Yes. Just like we did on the first question, we are going to resolve forces in the x direction and sum them up, and also sum up forces in the y direction, right? Because to find the resultant force, which is the resultant force, is going to be equals to the force in the x direction, or the summation of forces in the x direction all squared, plus the summation of forces in the y all squared. So which means the first thing we do would be to find the sum of forces in the x. So the sum of forces in the x is going to be equals to a negative 30 newtons plus this we have to resolve to find its component along the x direction. Okay, so that x there will be your sine 30 equals to your adjacent, which is x, over the hypotenuse, which is 65, which means your x there will be 65 sine of, no, that's close. Sorry. We've got adjacent and hypotenuse. So that's cos of 30 equals to the adjacent x over the hypotenuse, which is 65. So your x is equals to 65 cos of 30. We're just reminding each other on resolving. So that will be 65 cos of 30. And which other force do we have that is in the x direction? So you can resolve the 20 Newton force along the x-axis. So we can resolve it from here. So this angle is 70 degrees, as you can see. That angles in a right angle add up to 90. So if you have to form a right angle there, this is your 90 degrees. So you also have got your x there, which is your adjacent, and your hypotenuse, which is 20. All right, so if you follow again, you've got your adjacent and hypotenuse, so that will be cos 70 is equals to adjacent over the hypotenuse, which is 20, which means you could call it x1 there will be equals to 20 cos of 70. So which means that, and you can see that it's on the negative side of the x-axis, so it becomes negative 20 cos 70. You do the same thing for your y-axis. I'm going to punch all at the end. Summation for the y-axis. So that 30 does not contribute. So this y, 65 Newton force has a component in the y. So that becomes opposite and hypotenuse. So that will be your sine of 30 equal to your opposite, which is y, over the hypotenuse, which is 65. So which means your y is 65 sine 30. So that's 65 sine of 30. It's in the positive. Then we've got that 20 Newton force, which is in the negative. So that becomes minus. So if you form a right angle triangle there, that this becomes your y1, which is your adjacent in this case, because it's in between your angle and the right 90 degrees. So you've got your adjacent and hypotenuse, which is 20. So your y1, that will be your cos of 20 equals to your y1 over the hypotenuse, which is 20. So which means your y1 is equals to 20 cos 20, right? Y1 is 20 cos 20. Then we can punch this, of course. Start with the y-axis. Let me know, guys, if you've got any questions. And also, if you're following, please do let me know in the comments that you are following. 65 sine of 30 minus 20 cos 20. 13.7. Okay. And then you do the same for the x-axis, which is negative 30 plus 65 cos of 30 plus, oh, it's a negative, minus 20 cos 70. 20 cos of 70, you get 19.45. 19.45. Which is 19.5, right? 19.5. All right. 20 cos 70. Negative 30 plus 65 cos 30 minus 20 cos 70. 20 cos 70. Just checking if everything is correct. 30, 20. Right. What do we do next? What is the question asking for? What is the question asking for? Let's look at the question. Says find question says what is the direction of the resultant of these two forces? So just like we did, so your tan theta be opposite over the adjacent. Which is your 13.7 over 19.5. So your theta is equals to tan inverse of 13.7 over 19.5. Let me punch this. So we punch that. Let's punch that. If you're punching, also punch with me, please. Then function tan inverse tan inverse 13 point over 19.5. Right, there we are, and we get 35 degrees, and both of these are in the positive quadrant. So your y is positive, your x is positive, so which means that our resultant should be here. So this is your summation of f and just summation of fx. So I'm moving from the positive x-axis, that becomes your angle theta, which is equals to 35 degrees. Should be able to check that to see 35. So that is indeed correct. So what we've done is quite correct. So let me know, guys, if you've got any follow-up questions on that. And now I'm showing question 10. So I'll just pause for a while. If there are any questions or follow-ups on question 9. So what we've just did there was to first find the sum of forces in the x direction, and take note that all vectors at an angle will have to be resolved. So you resolve in the x-axis and also resolve in the y-axis, which is when you're now summing the forces in the y direction. Right? Don't forget to resolve. I also did try to go step by step resolving each and every vector. So if you're still having challenges with resolving, please reach out so that you could be assisted. Just try to break it down. So in resolving, just consider a right angle triangle. Identify your sides, adjacent, hypotenuse, and opposite. Then determine which side you're looking for. Then that will be your unknown side. So I hope that this working will simplifying the aspect of resolving. Shall we then move to the last question, which is on question 10, which reads, if a vector A is added, let me see if it's visible. Yes, it is. Says if a vector A, just a bit. It says if a vector A is added to vector B, the resultant is that. If B is subtracted from A, the result is that. What is the magnitude of A? So we're looking for the magnitude of vector A. So we're being told, so you can write it like this. We're being told that vector A, the sum of A plus vector B, is equals to 6i plus j. Okay. And we're also told that if B is subtracted from A, which means that will be A minus B, which is going to be equals to negative 4i plus 7 in the y direction. So we're being asked to find vector A, or the magnitude of vector A. Magnitude of vector A. So you've got two equations, equation 1, equation 2. So you have to treat these two as simultaneous equations. Okay, so if you can say equation 1 plus equation 2 to eliminate B, right? So if you can say the sum of those two, A, vector A plus vector B plus equals 2. Oh, there's a negative sign. This is a negative sign. Hey, how's it going? Yeah, I'm still live. But I'll be finishing in the next 10 or so minutes. Right. So which means that what we sum on the left-hand side, we also sum on the right. So this will be 6 plus j plus negative 4i plus 7, okay, like that. So you realize that if you open the brackets, there should be vector A plus vector B plus vector A minus vector B, and then this side will be that. Now this is just summation. You realize that vector B will cancel out, which means you remain with 2a, like that. And there you have 6i minus 4, which is negative. 6 minus 4, that's 2 in the I direction. Then j, in the sum of the j direction will be 8. Okay. So if you can simplify, vector A will then be equals to I plus 4 in the j direction. So that's the vector, that's vector A. But the question is asking us to find the magnitude. This, then you should be able to find the magnitude of vector A, which is equals to the square root of that plus 4 squared. So the sum of that square root is 17. So if you put the square root of 17, what do we get? Square root of 17, 4.12. 4.12. So this should be the magnitude of vector A. So let's say, do we have an option like that on our answers? 4.12 or we put 4.1. So that still should do. Check our answer. So it does confirm that our answer is correct. So that's how you treat, that's how you'd solve this problem. And like I indicated, that these were the 5 selected questions for the day. And in case you've got further questions, please feel free to reach out through email to any of the tutors. We'll be very happy to assist. So from today's tutorial, I would like to say this is the end of it. I don't see any further questions on the chat. I don't see any further questions on the chat. So yeah, this is it, guys. So more questions are going to be solved tomorrow. Be sure to join in tomorrow's tutorial, which will be looking at question 11 to 15. And if you can, please do try out these questions ahead of time. Then you can always present questions that you've found yourself having challenges with. But otherwise, from me and all the guys that are in the studio, it's a goodbye.